Good day. Just seeing if this thing is on. So looks like we've got the connection. There we go. Okay, good day. Welcome. Hoping everyone is having a wonderful start of December. And yeah, this will probably be the last live stream for 2020. Not for sure if I'm going to pick these back up in the spring. Just kind of seeing how how the things roll. But yeah, so for the live stream, starting off with a question. It was asked in the last live stream, but unfortunately that was an active question on one of my tests. The person had already taken the test, but just in case there was a few folks who were taking it really late, I didn't want to, respond too quickly. So the question was, what is a star? And that was one of the questions I put on the test. And so for this one, I was looking for, and I do apologize for the glare in my glasses. I don't know how to get rid of that. Anyways, so in this particular case, I was looking for a definition that incorporated a couple of things. So one, they are very large. They're made of gas/plasma. Probably plasma is a better description because they're super hot. But they're made of a lot of it, and they're incredibly large. So, if we look at our sun, the vast, vast majority of our solar system's mass is in the sun. So they are big. And our sun, by the way, is not a particularly large star. It's kind of a, normal star, So with that said, these things are going to be large. And this is actually critical for what they're doing. So they're big enough that now all of a sudden they have a lot of gravity. And that gravity is going to have a couple effects. One is, of course, going to affect everything around them. But the matter that is making up the sun, or I should say a star. Our sun is a star. But the matter that is making up a star is going to be pulled together very tightly. So the pressures in the inner parts of a star are going to be at ludicrous levels, as well as the heat. So as you take gas, you start crushing it down, it's going to heat up. You can actually feel this if you take a piston and you just kind of squish on the piston and you push down. It'll actually warm up. This is going to be Gay-Lussac's law. So as you increase the pressure, the temperature is going to go up. And it's kind of weird. We normally think of the pressure and temperature, the temperature controlling the pressure, but you do go the other way. You crush it down, your temperature goes up, and then it cools off again. But as you got your star, as it's pulling the gas closer towards the center, it's pulling it with enough force. It's going to start heating up. It's going to start getting lots and lots of pressure. So now all of a sudden the gas particles are bouncing around, and they are bouncing around with just ludicrous levels of force. Ones that on Earth we can basically only generate by detonating an atomic weapon. There is some work on trying to generate it with lasers. In one of those projects, I'll believe that when it works because it seems nuts, but the people probably said the airplane. But yeah, so these pressures are of absolute ludicrous levels, enough so that the atoms are being crammed together fast enough they'll actually stick, and so you can undergo fusion. And so now you've got your fusion. You're taking hydrogen, you're crushing about 4 hydrogens together to make a helium. And this is then going to give you energy. It gives you energy based off of E = mc squared. Because it turns out the mass of that helium is just a tiny bit less than the mass of the originating hydrogens. And, well, you do that a lot, and that little tiny bit of mass can add up a lot, and then E = mc squared, the c part is the speed of light. So, yeah, the mass times speed of light squared. Speed of light's ridiculously large, so you're going to get a really big number for your energy. So now, then you've got incredible pressures because of the size of the star. Then this is going to allow you to do nuclear fusion. This is what separates a normal star from a brown dwarf. A brown dwarf is going to be basically a star, except it's a little too small, and it's not going to be able to start nuclear fusion. Just because the pressures inside they're obscene, but they're not sufficiently high to actually start nuclear fusion. And so they may have some warmth to them from kind of packing in, but they're going to cool off. They're not generating their own heat. And so if I'm thinking of a star, the characteristics of the star that I'm going to be thinking about, gigantic ball of gas that is so big that it's undergoing fusion. And that is going to be the core of what I would call a star. Now, of course, we can go into all kinds of features about this. The bigger the ball of gas, the more fusion we can do, the more intense that fusion is, so the more heat we can make, and the hotter it gets, and it's going to, of course, change colors, etc. So at low temperatures, it's going to be kind of, visible in the infrared, going on to reddish, and then it moves into, visible spectrum, from red to yellow. There's no green. So a green star doesn't exist because if it was green, then it would actually look white to us, which is kind of this interesting because green's in the middle of the spectrum, and the way the black body curves work, the way the light coming off of something because it's hot ends up being spread out. It's kind of spread out as a Gaussian curve. It kind of tails off on both sides. So to our eyes, kind of that green hot would actually look white hot. Now, of course, you can go higher, and if you can get into blue stars, and those things are going to be very, very big. They burn through the fuel. Counterintuitively, normally we think of big things as lasting longer. For stars, because their rate of fuel consumption is so much higher, it's going to actually last less time. So the blue giants aren't going to have particularly long lifespans. Now, there are red giants, which are very big stars, but they're not very massive stars. I mean, they're still massive. I mean, they're a star. But in that case, you've got this interesting pull and push with respect to the outer layer of gases, and the red giants. Those have kind of spread out a bit, become a little bit larger. And so you've kind of got a little bit of a less dense star. It's still, it's a very big star. It's still a star. And as they spread out, they're now a cooler star. They're kind of changing over which atoms are becoming fused together to other atoms. So as always, anyone in the comments is welcome to chuck some questions in. I'll kind of ramble on a little bit longer before calling it a day for the last live stream of the year. But yeah, so stars, key thing I'm looking for, big gigantic ball of gas, lots and lots and lots and lots and lots of math, nuclear fusion, not math. There's lots of math involved, but nuclear fusion going on in there. Yeah, so looking kind of, grading on the last couple tests, typically speaking, and this is kind of one of those, useful for most students, no matter who your instructor are. If there's ever an essay question, there's usually a couple of things going on. Assuming your instructor is not an English instructor and actually grading English. I'm usually got a couple of pre-built ideas. So when I come up with a question, I'm like, here's what I want you to do. Now, some students will come up with crazy answers. They're like, you know what? Y'all interpreted the question in a way that I wasn't expecting, but it is a legit interpretation. So, okay, I'm going to have to readjust my thoughts on this. And I've had to do that a couple of times. I haven't had to do that too recently, but I have occasionally done that. So of course, it's kind of like a multiple choice question, but there are no multiple choices, and it's kind of multiple ones. So I'm looking for kind of a list of things. And to be honest, for my class, most of the times when I have an essay question, if you just wanted to put a bulleted list, frankly, you'd make me happy. It's a lot easier to read a bulleted list than just, gigantic block of text. Please put some paragraphs in there. Either way, you're doing this. But yeah, so you can do. So I'm grading these things, I'm looking for a couple of key items, and basically the points are each one you get some fraction of, the points. So if there's 5 items, you get 20% for that value of the question. So a fifth, typically speaking. Now, there's also variations. There's sometimes these key items, which, are going to be weighted more or something like that. So, you're kind of wanting to flush things out. Of course, you're also not wanting to get in wrong information because, 2 rights and a wrong, that's not as good as just 2 rights by itself. So, that's going to have to be adapted. Also, make sure it's original work, because as an instructor, I'm always grading. It's the best way to do this. And if anyone's, going into education, going to be grading themselves, here's the pro tip. Whenever you're grading an assignment, you're always grading one question at a time. Okay, there's times when I don't do this. I mean, let's just be honest. But typically the best way of doing this is you don't grade one test at a time. You grade one question at a time. So let's say I've got 50 students with a 10 question test, which is going to take forever to grade. But anyways, so instead of grading, Alice Apple's test and then Bob Borloff's test, et cetera, what I'm going to want to do is I'm going to take question 1. I'm going to grade all 50 question 1s. Then I'm going to grade all 50 question 2s. And there's a couple goals here. One is, as I'm grading, especially if there's any subjectiveness to these guys, which of course, if there's anything other than a math problem or multiple choice, there's going to be. But if I'm grading them that way, I'm going to keep in mind what I'm doing, because when it comes to rubrics, it's like rubrics are great, except for I can't think of all the wrong answers possible. And so there will be answers that I never imagined on the test. And so I'm going to have to make a spot judgment and going, okay, this answer is not 100%. It's not 0%. I'm going to have to give the answer, this percentage. Well, 3 people do that. 3 people should get the same percentage, at least as best as possible. It's a lot easier to do that if you grade all of the questions in a row. That way it's like, okay, I just did this. This person made the same mistake. I gave them 6 out of 10 for that. So I'm going to give this person 6 out of 10. If I do one test at a time, it's very easy to forget and very easy to keep those, or very hard to keep them straight. So if you do it one question at a time, it's a lot easier to be much more consistent. Once again, we're all human. It's not perfect. It's also, if these are essay questions, going, wait, didn't I just read this? This looks really familiar. Like, really, really familiar. Oh, here it is. Hey, these are the same words. This is not okay. This is going to throw some paperwork. So, it's another thing you're doing. So by grading them one question at a time, it does help spot less than honest students. Or alternatively, and this is, you always have to, fish around for this. I usually Google these guys, sometimes, if it's an open book test, okay, what did the book say? Or what did the internet say? What did Wikipedia say? Okay, these 3 or 4 students are basically copying Wikipedia. Is that okay? It depends on the test. And so, that's definitely kind of at least I don't think they're cheating. Oh, I mean, copying. But yeah, anyways, so generally speaking, for anyone grading tests, do one question at a time. So much better than trying to do one test at a time. Now, obviously, if you're doing multiple choice or something where you just get the answer key and you go, then yeah, just do the whole test. That's usually a lot easier. But if you're doing any kind of subjective anything, one question at a time, always your best bet, whenever doing this. And for anyone answering essay questions for mine, bulleted lists are always wonderful ways to answer. Make life easier for me. Anyway, so some of my other students are doing infographics. I've done a couple things on infographics. If you're one of my students watching this doing an infographic, make sure it's a graphic infographic. I mean, not graphic isn't obscene, but it's very pictorially represented of an infographic. If it's an essay with pictures, I'm not going to be too generous with those. So, make sure it's a graphic. Otherwise, the year is coming to a close. This has been 2020. It's definitely been a weird year. COVID really changed the way that I have to teach. I don't like it. I'm going to have to do it again in the spring. But hopefully, coming on, next year we can go back to normal with, a lot better ways of teaching. I like doing a lot of group activities. That didn't work out this year. I don't like the online tests. They're not as good of a test. Especially since a lot of the content I teach is fairly foundational, very low on Bloom's taxonomy, the knowledge and the understanding level. And it's really hard to make a good online test for those because, open note kind of thing. I know there's a lot of folks who try to not open note tests, but it's like, no, this is getting ridiculous. I'm just going to have to try and write it for an open note test. And those are never as good as kind of a nice closed note test. At least never as good on a course that's heavy on, the bottom part of Bloom's taxonomy. Because, people kind of downplay the bottom part of Bloom's taxonomy. It's like, oh, you should be in the synthesis and evaluation. Well, you can't do the top until you have the bottom. You can't build a house by building the roof first. You got to build the foundation. Although that is actually how grain silos are built. You build the roof and then you jack it up and put the next layer on. But still, the foundation is put in first. You still have to do the foundation first. And so we got to get the bottom foundation part of the Bloom's taxonomy done first. And when it comes to tests, normally the best way of assessing those are ones where it's not open note. Now that said, I've liked some of the video based systems. Definitely give some new options. So I will definitely be keeping some of the things that I've learned in 2020, but I'll be looking forward to transitioning back once this whole mess is over. But yeah, so that's basically it for me. I'm going to go ahead and sign out for the year for the live stream. I actually am working on a new video to put up. The audio for the first microphone did not come out so well, so I'm hoping the audio on the second microphone came out well, which was why the second microphone was there. But yeah, chucking up a new video on chemistry demonstration. I have to figure out what it's actually called. It's the one where you blow out a candle by pouring carbon dioxide on it. So it's a fun little demonstration. Hopefully the video will be interesting. Otherwise, for everyone, happy holidays, Merry Christmas if you celebrate. I think Hanukkah is coming up pretty soon, so happy Hanukkah if you celebrate that, or whatever other holidays you might be celebrating, or simply, the winter, and the transition to 2021, which, okay, the dumpster fire won't be put out by January 1st, but, hopefully the dumpster fire will be going out soon. So with all that said, have a wonderful day. Best of luck on whatever you are doing. And this is Dr. T signing off.